In this example, we are proving mathematical statements using a logical argument. Now, in previous examples, we were not proving. We were coming up with conjectures, and let's talk about the difference between those. So in this case, we have John. He's discovered a pattern when adding digits. So when you do this, this is called inductive reasoning. You're coming up with a whole bunch of examples. In this case, there's 3 of them. They support the conjecture. It is not a proof at this point. So integers, of course, are numbers that are whole numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but it's also the negatives of all those numbers, and it includes 0. So those are your integer numbers. And we want to add integers. We have 5 consecutive integers. So 1, 2, 3, 4, 5. If you add them together, you get 15. And we notice that 15 is equal to 3 times 5. Minus 15, minus 14, minus 13, minus 12, minus 11. When you add them all together, you get minus 65. The median, or middle term of that, is minus 13. And when you multiply minus 13 times 5, you get 65. And minus 3, minus 2, minus 1, 0, 1. The median is minus 1. We multiply that by 5, and we get minus 5. So in these 3 examples, we see the pattern, and it supports the conjecture. The sum is always 5 times the median of the numbers. So the key word here is these are conjectures, and we now want to prove them. So in order to prove them, we want to prove a mathematical argument showing that a statement is valid in all cases. There are no counterexamples. So how do we do that? Well, let's take a look at this. The key to doing these is to let x represent an integer. So we will rewrite these integers using x, x plus 1, x plus 2, and we want to make it as easy on us as possible. So if you think about what would be the easiest way of doing it, since we're interested, the median's a special number, so why don't we make that one the x? And then the numbers that are bigger than x would be x plus 1 and x plus 2. The 2 numbers that are smaller than x would be x minus 1 and x minus 2. That would be the simplest way of doing it. You could actually do it a number of different ways, but I like to do things the easy way. So when we write this out, the sum of those 5 integers would be x minus 2 plus x minus 1 plus x plus x plus 1 plus x plus 2. Now when join together our like terms, we have x plus x plus x plus x plus x, which is 5x. When we look at the numbers, we have minus 2 and minus 1, which is minus 3. We have plus 1 and plus 2, which is plus 3. They'll cancel out to give us 0. Now since x represents the median of 5 consecutive integers, 5x will always represent the sum. John's conjecture is true for all integers. That is a proof.